Hey there, train enthusiasts and curious minds. Whether you're a lifelong rail fan or just someone who's always wondered about those powerful machines thundering down the tracks, you're in the right place. Have you ever wondered how trains, those massive machines of metal, actually work? What's going on beneath all that steel and noise as they glide across the landscape? It's a question that has fascinated people for centuries. Since the very first steam engines chugged into existence, people have been captivated by the power and mystery of trains. From the earliest steam engines puffing clouds of smoke to today's sleek, high-speed bullet trains racing through the countryside, trains have played a vital role in shaping our world and connecting distant places. Trains are like giant metal snakes, slithering across the land on ribbons of steel. Their tracks stretch for thousands of miles, linking cities, towns, and even entire countries together. They carry people to work, families on adventures, and goods that keep our economies moving. From fresh produce to heavy machinery, trains transport almost everything you can imagine. But how do these iron horses actually move? What makes them go? What's the secret behind their incredible strength and reliability? Get ready to dive into the fascinating world of trains. We'll uncover the science, the engineering, and the history that make trains such an enduring marvel. We'll explore the inner workings of these incredible machines, from the powerful engines that drive them forward to the intricate systems of wheels, tracks, and controls that keep them running smoothly and safely. So, hop aboard as we embark on a journey to uncover the secrets of how trains work. Whether you're here for the nostalgia, the technology, or just the thrill of the ride, there's something for everyone on this adventure. Before we can understand how a train moves, let's take a closer look at what makes up this incredible machine. Trains are more than just vehicles. They are complex systems made up of many important parts, each with its own job to do. To really appreciate how trains work, we need to get to know these parts and see how they fit together to create a powerful moving whole. Think of a train like a giant puzzle, where every piece is essential. If even one part is missing or not working, the whole train can't do its job. Each component is designed to work in harmony with the others, making train travel possible. First up, we have the engine, often called the locomotive. This is the powerhouse of the train, packed with technology and strength. Whether it's powered by electricity or diesel, the engine is what gives the train its energy and speed, pulling everything behind it. It's the muscle that makes everything go, turning fuel or electricity into motion. Next, we have the wheels, those giant, sturdy steel discs. They might look simple, but they're specially designed to grip the tracks and support the massive weight of the train. Speaking of tracks, they're like the train's roads, stretching for miles and miles. Tracks are carefully laid out to guide the train safely to its destination, keeping it on course and allowing it to travel smoothly over long distances. And finally, we have the carriages. These are the passenger cars or freight wagons that the train pulls along. Carriages are where people sit, relax, and enjoy the ride, or where goods are safely transported across the country. Each part is essential. The engine provides the power, the wheels grip the tracks and keep the train moving, the tracks guide the way, and the carriages carry the load, whether that's people, mail, or heavy cargo. Together, these parts form the mighty train, a marvel of engineering that connects cities, moves people, and delivers goods all around the world. The engine is the heart of the train, the source of its power. Over the years, there have been three main types of train engines: steam, diesel, and electric. Steam engines, the earliest type, were powered by burning coal or wood to heat water. This created steam, which pushed pistons that turned the wheels. Diesel engines, on the other hand, burn diesel fuel to generate power. And electric engines get their power from electricity, either from overhead lines or a third rail. No matter the type, the engine's job is to turn a rotating shaft called an axle. This axle is connected to the wheels, making them turn and propelling the train forward. It's a beautifully simple, yet powerful concept. The wheels and tracks work together in perfect harmony, like dancers gliding across a ballroom floor. But have you ever wondered why train wheels are shaped the way they are? Train wheels aren't just flat discs, they have a slightly conical shape, with a raised edge called a flange. This unique design helps the train stay on the tracks, even when going around curves. The flanges prevent the wheels from slipping off the rails, ensuring a smooth and safe ride. The tracks themselves are equally important. Made of heavy-duty steel, they provide a smooth and durable surface for the wheels to roll on. The rails are carefully spaced and leveled to ensure a comfortable ride and prevent derailments. Section 5. Full steam ahead, safely. Starting and stopping a train. In this section, we'll explore what it really takes to get a massive train rolling and, just as importantly, how to bring it to a safe stop. So starting and stopping a train, especially a huge freight train that can weigh thousands of tons, is a pretty complex process. Unlike smaller vehicles, trains have a lot of momentum, and that means every action has to be carefully planned and executed. It's definitely not as simple as just hitting the gas and brakes like you would in a car. Trains respond much more slowly, and the controls are designed for precision rather than speed. To get moving, the engineer slowly increases power from the engine, carefully monitoring the train's response. Too much power too quickly can cause the wheels to slip, especially if the rails are wet or icy. This gradual increase in power boosts the rotational force on the wheels, causing the train to accelerate smoothly. It takes a lot of skill to balance the throttle and avoid sudden movements. Now, stopping a train actually requires even more finesse. Because of their size and weight, trains need a long distance to come to a complete stop, sometimes over a mile. Trains use these powerful brakes, usually air brakes, that apply pressure to the wheels to slow them down. The braking system is distributed along the entire length of the train, ensuring each car slows at the same rate. The engineer has to apply the brakes gradually to avoid a jerky stop. If the brakes are applied too quickly, it can cause the train to lurch or even damage the cargo and cars. And really, safety is paramount when it comes to trains. Every step, from starting to stopping, is done with safety in mind to protect both the crew and the public. That's why signals and communication systems are used to control train movements, prevent collisions, and ensure everyone gets to their destination safely. The entire process is a careful balance of power, timing, and teamwork. Section 6. Fueling the journey. Power sources for modern trains. Modern trains have moved beyond coal-fired steam engines, embracing cleaner and more efficient power sources. Today, most trains are powered by either diesel or electricity. Diesel engines are still common, especially for freight trains. They offer good range and power, but they do produce emissions. Electric trains, on the other hand, are becoming increasingly popular, especially for high-speed passenger trains. They get their electricity from overhead lines or a third rail, and they produce zero emissions at the point of use. As technology advances, we can expect to see even more innovative power sources for trains, such as hydrogen fuel cells and battery-powered locomotives. The future of train travel is looking bright. Section 7. Guiding the way signals and switches on the rails. Imagine a busy highway with no traffic lights or signs. It would be chaos. The same is true for trains. That's where signals and switches come in. They act like the traffic cops of the railway, ensuring that trains run safely and efficiently. Signals, those familiar red, yellow, and green lights, tell the engineer when to stop, slow down, or proceed. Switches, on the other hand, are like railroad intersections, allowing trains to change tracks and go in different directions. These systems are essential for preventing collisions and keeping train traffic moving smoothly. Modern rail networks use sophisticated computer systems to control signals and switches, further enhancing safety and efficiency. Section 8. Passengers and cargo. The importance of trains in our world. Trains play a vital role in our world, transporting people and goods over long distances. Passenger trains carry millions of people every day, connecting cities and towns. Freight trains, on the other hand, haul everything from raw materials to finished products, keeping our economy running. Trains are incredibly efficient, especially for moving large quantities of goods over long distances. They are also more environmentally friendly than trucks, making them a sustainable transportation option. As we look for ways to reduce our carbon footprint, trains will undoubtedly play an even more important role in the future. Section 9. Conclusion. Trains are awesome. So there you have it, a glimpse into the fascinating world of trains. We've explored the different parts of a train, from the powerful engines to the intricate systems that keep them running smoothly. We've learned how trains start and stop, how they get their power, and how they are kept on track. Trains are incredible feats of engineering, and they play a vital role in our world. They connect people and places, transport goods, and contribute to our economy. Next time you see a train, take a moment to appreciate the ingenuity and complexity of these amazing machines. And who knows, maybe you'll be inspired to learn even more about the wonderful world of trains.